Alright, in the last lesson we learned the binary system and how to convert to and from decimal. Binary was a base 2 numbering system. Decimal was the normal base 10 system we use every day. Hexadecimal is a base 16 numbering system, which is also commonly used in digital electronics. So basically, I'll use all three numbering systems at the same time so you can see and grasp how they correlate. Hexadecimal is based on a nibble. So two hexadecimal numbers would represent a byte, each hex number representing the lower half and the upper half of the byte. So a decimal number in our example might be 203. In binary, that would be 128 plus 64 plus 8 plus 2 plus 1. In hexadecimal, we break that binary byte into two nibbles. The first one will be 1100. The second will be 1011. Now a nibble can have how many combinations? 16. You can represent up to the number 15, but don't forget that 0. The 0 is important, as is our 16th combination. It is our 16th combination, available using 4 wires to represent the number, right? But we only have 10 different digits to choose from in decimal, 0 through 9. So how could we represent the other 6 digits above 9 in hexadecimal? We use letters. So 0 through 9 represents, well, 0 through 9. The 10 is represented by the letter A. B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. We now have 16 different characters to represent our hexadecimal number. Hexa comes from the ancient Greek word for 6, and we're using the decimal numbers of 0 through 9 as well. So we're using the decimal system plus another 6 characters, hence the name hexadecimal. So in our second nibble, the most significant nibble, even though it is part of a byte, we treat the bits as starting over again from 0, in effect. This is the least significant bit in the nibble. This is the most significant bit. In decimal, the least significant bit represents 1, then 2, then 4, then 8. So with two binary nibbles of 1100 and 1011, in decimal, the first one represents 12. Binary bits 4 plus 8 equals 12. So the letter for 12 is, in hexadecimal, C. So the most significant hex nibble is C. The least significant nibble is 1011 in binary, which would be 8 plus 2 plus 1, which equals 11 in decimal. 11 in hexadecimal would be B. So our hexadecimal representation of this byte would be CB. So here's another byte. See if you can figure out both the decimal and the hexadecimal numbers to represent this byte. Pause the video if you need to. Alright, got it figured out? In decimal, the byte is 62. 2 plus 4 plus 8 plus 16 plus 32 equals 62. The most significant nibble is 3. 1 plus 2 in binary in the nibble. The least significant nibble is 14. So written in hexadecimal, it's represented as 3E. So hopefully you got that right. If you didn't, try and see where you went wrong. It's confusing and complicated at first, but it's critical that you understand the interactions between binary, decimal, and hexadecimal, as they're used interchangeably throughout digital electronics. So let's practice a little bit more. Here's another binary byte. See if you can figure out both the decimal numbers and the hexadecimal numbers. Again, pause the video for as long as you need. Alright, think you got it? First, look at the byte itself. This is the least significant bit, representing 1, which we add with 32 and 128, which gives us a decimal number of 161 for the byte. We break that byte into two separate nibbles. The most significant nibble is 2 plus 8, or 10. 10 in hexadecimal is represented by the letter A, so that's our most significant hex character. The least significant nibble is 1. That's it. So the least significant hex digit is 1. Our hexadecimal number is A1. Let's now work in the other direction. You have the hexadecimal number D7. Convert that into decimal, 2 binary nibbles, and a binary byte. Again, pause the video and take as long as you need. All right, in decimal you should have gotten 215. Your binary byte should look like this, 11010111. And there are your 2 nibbles. Is that what you got? Let's do one more conversion and then move on. Convert the hexadecimal number 0b into decimal, binary, and 2 nibbles. Again, pause the video and take as long as you need. Okay, so you should have gotten a decimal number of 11, a binary number of 00001011, as well as those 2 nibbles. Hopefully you're getting a handle on this, but we're going to have plenty of opportunity to practice on that one.